All right, good afternoon, everybody. We're going to go ahead and start into section 3 of our notes. Now, my hope is that as people are watching these videos, that you actually are taking notes and not just staring blankly at the screen and hoping that it sticks. Because a lot of this information is very key and it's little nuances and little things that may not be recorded in the textbook. So, I'm going to go ahead and get started. We're going to talk about learning goal 3.05, 3.06, and 3.07. You notice that 3.06 is covered in an inquiry-based activity as well. So we're not going to go deep into what it means, but we'll give you a little bit of an overview of how it's going to overall react. Now, we're going to talk about the 3 types of reactions. So this is the first time we're actually getting into what are the types of reactions per se. Now, the first one that we're going to deal with is called a precipitation reaction. The key here is usually going to be that it forms some sort of insoluble solid. This is going to be usually a double replacement or a metathesis reaction. Depending on who wrote it or what you may see in the practice, you're going to see this type of reaction. Now, with a double replacement reaction, it's going to form a precipitate or some type of gas, most times a precipitate. This is going to be usually ionic substances dissolved in a water or any type of solution. Now, if we're looking at the example of what we have here, we may have had barium sulfate or barium chloride for some reason formed with some other compound that contained a chromate ion. Now, once they get into solution, you notice that they begin to break up into their own ions. We're going to get a couple other things that form from it. Now, once we have put them in solution, the ions will begin to attract to each other. And that's when you're going to start to get what you're seeing right here at the bottom. Notice that we have these substances that are sort of falling to the bottom here. This is going to be our barium and our chromate ion are forming compounds. Now, this is what it'll actually look like when we get into an actual solution. So we may have mixed these 2 clear solutions and we begin to get this whitish yellow substance that forms at the bottom of the beaker. This will be our precipitate. Now, how do we know which is actually going to form? We're going to get to that in just a second. Now, precipitate basics. With any type of solution, we need to deal with a couple of things. One, whether it is soluble or whether it dissolved in solution, completely dissolves, or we say aqueous, or whether it's insoluble. Now, you notice that I put in these examples that for if it's soluble, you're going to see AQ in the reaction. If it's solid, you're going to see an S in the reaction. You may see this at the beginning or in the end. Either one is letting you know what you're dealing with here. Now, another little note, and I made sure to put it in bright red so you'll have it. Insoluble and slightly soluble are often used interchangeably. When we say something is insoluble, really what it means is very, very little of it actually dissolves, and so it's basically insoluble. It's basically not dissolving at all. But it may be just slightly soluble. We're going to talk about that when we get to complex ion equilibrium and all that fun stuff, but that's later in the year. Now, these are basic rules that we need to memorize. Notice I'm saying you need to memorize them. Make sure to put it clearly in order to understand whether something will be soluble or insoluble in solution. You need to have these in your mind. Now, take some time, copy these down. Most nitrates, salts are going to be soluble. Most alkali metals, group 1A, those that we talked about, are going to be soluble. We'll talk about the reason why in the next couple of units. Most chloride, bromide, and iodide salts are soluble, except for, and it gives you a couple of exceptions to memorize. Again, number 4, sulfate salts are soluble, except for, and it gives you the 4 that are there: barium sulfate, lead sulfate, mercury sulfate, and calcium sulfate. Most hydroxides are only slightly soluble. The ones that are going to be definitely soluble are going to be sodium, potassium, barium, calcium, that are going to be somewhat soluble. These are going to actually form most of your stronger bases, so they will actually dissolve very, very readily. And last but not least, we're going to run into some sulfides, carbonates, chromates, and phosphates that are going to be slightly soluble, except for those that we went back to rule 2, which are going to be our alkali metals. So our group 1 metals and ammonium are going to usually be soluble with these. Now, how do we describe reactions in solution? we have a couple of different ways that we're going to see this. The first is what we're normally used to. We have the formula equation, or the complete equation, molecular equation. It gives the overall reaction stoichiometry. It gives you how many moles of each compound are there present, and the states many times are what are also going to be there. Now, this is what we're going to use the solubility rules to determine whether we form a product or not as we mix these different things together. Now, the next type of reaction, this is one that's going to be slightly different. It's going to be called the complete ionic equation. The reason why it's the complete ionic equation is regardless of what's going on, you notice that it includes all of the ions the whole way through. The only thing that changes from being an ion, because we form silver chloride as a solid, it's the only thing that you don't see in its ionic form. For an complete ionic form, we must have everything, and then we work to balance it and so forth. Now, the last type that we're dealing with are net ionic equations. Now, in my mind, I think just like a paycheck. When you get your paycheck, there's usually the gross amount that you make, but then there's the net portion. That's the portion that you actually take home. In the situation here for a net ionic equation, this is the part that we need to pay attention to. If I go back in the slide, you notice that the only things that come together to form silver chloride are, I have my silver ion here, oops, sorry, I won't let me go over there, and the chloride ion. So, since those are the two I need to make my product, that's all I'm going to write. I'm going to have Ag plus Cl minus is going to yield AgCl. Simple, straightforward. Now, anything that is a spectator ion, we talked about the fact that a spectator ion, spectator at a game is just there to watch. Spectator ions are just there in solution, but they don't interact, they don't react, they just sort of float there. Since they are spectator ions, we do not include them in either side of the equation because they basically do the same thing in both situations. Okay? Now, thinking through the overall process, if I have to go through and do stoichiometry for a problem that occurs in solution, we need to look at a couple of steps. First thing, we need to identify the species that are present and combine in the solution. That's going to help us out a whole lot. Now, right after that, we're going to write the balanced net ionic equation. This is going to help us to be able to get, just like we would our regular stoichiometry, this is going to let us know how much of each of the substances we're dealing with, even in their ionic states. Next, calculate the moles of the reactants, figure out which is limiting, calculate the moles of the products as required, and convert to grams or other units as needed. We're going to have plenty of practice with this, so please do not worry, don't fret. We're going to come back and be able to do a lot of these. This is where we're going to end this video for right now. Now, I will post and probably put a link in the description for some example solution stoichiometry problems. That way you can always go back and you'll be able to look at some of the examples, not only the things from the book, but also some extra practice that I give you on your own to work from. Go ahead, have a great evening, and I will talk to you later. Have a great day.